All right, so 19.2, we are going to stretch, compress, and reflect the tangent function today. Okay, so looking at the tangent. First thing I'm going to do is kind of the same way I played introducing the sine and the cosine functions to you. Okay, so what I want you to do is grab your unit circle, and we're just going to quickly create a table of values, and then I'll show you what a tangent function looks like. Okay. Okay, so I don't like the tables that they kind of provide. So I'm going to make my own table. It's up to you whether or not you want to write this table down. I don't know if it's necessary, but just so you know how we come up with the tangent. Yes, this is Miss Nolte, radio check. I've been waiting all class period for that. Okay. I'm going to turn it down because it's super distracting. Okay, so on your unit circle, when you're working with tangent, how do you figure out what tangent is? Y over the x. Okay. So all we're going to do is we're going to rotate around the circle, and we're going to do y over x. Okay. So the first spot is 0 radians, I guess you should say. So what is the ordered pair at 0? 0. Okay, so 1, 0. So if we do y over x, what do you get? What's 0 divided by 1? 0. Everybody okay with that? Move it along. No? You're unhappy with that? No? Oh, good. I thought you said no. Oh. Okay. So moving along at pi over 6, what's the ordered pair at pi over 6? So the square root of 3 over 2 and 1/2. Okay, I need a calculator. Somebody calculate this for me. What is 1/2 divided by the square root of 3 over 2? .577. Perfect. Okay, moving along, we then hit pi over 4, and you can see the ordered pair at pi over 4 is the square root of 2 over 2 and the square root of 2 over 2. So if you take the square root of 2 over 2 and divide it by the square root of 2 over 2, you get? It's hard to say, huh? And you just get 1, right? Perfect. Moving along, at pi over 3, the ordered pair there is 1/2 and a square root of 3 over 2. That I don't know. Can somebody please calculate the square root of 3 over 2 divided by 1/2, which would be the same as the square root of 3? 1.73, thank you. Moving along, we then hit pi over 2, and at pi over 2, the ordered pair is 0 over 1. So what is 1 divided by 0? Undefined. Oh my gosh. Undefined. Okay, so star this one because that one is going to become incredibly important here. Okay, do you guys mind if we move a little quicker through the unit circle? I'm going to skip a little bit. Okay, so I'm going to move on to 3 pi over 4. Okay, so at 3 pi over 4, we're looking at negative square root of 2 over 2 divided by, oh no, not divided by, and square root of 2 over 2. So if I have square root of 2 over 2 divided by a negative square root of 2 over 2, you get? Did somebody say negative 1? 16. Okay, perfect. Okay, what about at pi? Negative 1, 0. So if I take 0 divided by negative 1, you get? 0. How about 5 pi over 4? 5 pi over 4, the ordered pairs are a negative square root of 2 over 2 and a negative square root of 2 over 2. So if you divide the same thing by itself, you get 1. And moving along to 3 pi over 2. That ordered pair is 0, -1. So if I take -1 divided by 0, you get similar. -1 divided by 0. -1 divided by 0. Undefined, is everybody shouting undefined in their heads? Oh, good, excellent. How about at 7 pi over 4? We have a positive square root of 2 over 2 and a negative square root of 2 over 2, so you should get -1. Okay. We might as well hit 2 pi. What the heck? If we go back to 2 pi, we have 1, 0, so 0 divided by 1 is 0. Very good. All right, so now we're going to take this table and we're going to plot all the points. All right, so the first point that I'm going to plot, and this is the part you should write down in your notes. You got a question or just, oh, you're just excited. Okay, so the first point I'm going to plot is 0, 0. So note to self, the tangent function does cross the origin. Okay, at pi over 6, we're going to go up 0.577. So on my little table here, that's like right there-ish. Can you guys see that? So it's like a third of your pi over 2. Okay, at pi over 4, we're going to be at, oh wait, hold on, that's 1. My bad. Just kidding, it's down right here. Sorry, it was at 1/2, not 1. So my pi over 4 is at 1. Right there, there we go. My pi over 3 is at 1.7, so that's like right there. Ooh, that looks good. Pi over 2, important spot. What's happening at pi over 2? It's undefined. So what's happening with the graph if we have something that's undefined? There is an existing gap. It's not a hole. It's something we studied that we studied when we studied holes and yes, very good. Vertical asymptotes. Okay, so tangent functions have these vertical asymptotes. So this one has a vertical asymptote at pi over 2. Very important. Okay, moving on through the circle, we're now at 3 pi over 4. The corresponding y value, bless you, is at -1. So we're going to have 1 right there. When we hit pi, our y value is 0. When we get to 5 pi over 4, we're at 1. 3 pi over 2, what happens? Vertical asymptote. So that's another place where you're dividing by 0. It's illegal to divide by 0. Okay, at 7 pi over 4, we're at -1. And 2 pi, we come back and cross the x-axis. So clearly we have a, what does this look like? A bunch of little weird, ooh, very good. Okay, so I did this in the last class period, so I'm just typing in the tangent of x into the calculator so you guys can see what this does in fact look like. Okay, so this is existing from -2 pi to +2 pi. Okay, so the tangent function is literally a John Travolta dance party. Okay, there is a million John Travoltas dancing next to each other here. They all have their right arms up. Okay, so what I want you to draw is that the asymptotes are going to occur how often? Ooh, okay, which that's No, it's not every 90 degrees. It's actually every 180, so every pi units. Okay, so it occurs every pi units. So make sure that you draw a vertical asymptote at a negative pi over 2 and one at a positive pi over 2, and then you can go as far as drawing another one at 3 pi over 2. Okay, so your John Travoltas are going to exist in between each of these vertical asymptotes. Okay, so in your notes, you should have that the tangent of x looks like that. Okay, it is important for you to list that our vertical asymptotes exist at x equals, where do you see our vertical asymptotes? Okay, so at negative pi over 2, positive pi over 2, and every pi units, which is directly related to the period. Okay, now a period on a tangent function is a little different than sine and cosine. Okay, remember that one full revolution created a cycle for sine and cosine? Well, when we worked with the tangent, one full cycle around the circle creates 2 John Travoltas. Okay, well, we only want to draw 1 John Travolta as a period. Okay, so the period for 1 John Travolta is pi times b. Okay, so it's half the distance of sine and cosine. So make sure you identify that piece right there. That is different than sine and cosine. All right, you ready to do some compression-y stuff? Okay, so we are going to work with the exact same form that we did the previous two. So we're only doing stretching and compressing today. We're not going to do any shifts yet. So taking it nice and slow. Okay, next to your notes, I'm going to give you some important information. To find vertical asymptotes, all you have to do is take b and multiply by pi over 2. Okay, so your first one will exist at the negative version. The second one exists at the positive version. So b times pi over 2. Yeah, the first one is a negative, and then the second one is a positive. Okay, your reference points. We're going to have little reference points. Reference points. So this is reference points. Okay, we'll have 3 of them. Can you believe 3 of them? That's like the most we've ever drawn ever. I only highlighted 2. Does anybody know the third one? 0, 0. So 0, 0 will always be your third one. Comma, 0, 0. So 3 reference points. Good? Okay, so I did go over this example, even though it is done for us with the last class. I don't know if this is very valuable or not, but what the heck. So if our tangent, or excuse me, if our function is 1/2 times the tangent of x over 3, okay, can you look at that without looking down, no cheating? What's the amplitude? Okay, so our amplitude is 1/2. Okay, the b value is 3. So can somebody tell me what the period for this would be? How do you find period? Okay, so period is pi times our b, so in our case it would be 3 pi, right? Okay, so this is kind of interesting, I think, but check out these vertical asymptotes. Tell me the correlation between the period and where these exist. Do you see how they're related?
Freshmen, if your last name begins with the letters H, I, J, or K, please head to the auditorium. That's H, I, J, or K.
I like how they like spelled out the letters instead of doing 1 through there for the freshmen. They're freshmen. Yep. Anyway, sorry. Relationship between the period and where the vertical asymptotes exist. It's divided by 2, exactly. It's half the distance. So the kind of cool thing, at least that I think, or I start to notice in drawing trig functions, is all of these functions can be cut into quarters. Okay, so we have little sections and they just keep repeating themselves. Okay, so that's why all this stuff works. Do you see the correlation between the x value and the vertical asymptote? Divided by 2. It's half the distance. It's half and half. So from here to here, you multiply by 1/2. From here to here, you multiply by 1/2. You're just cutting things in half. Okay. All right, let's do an example. You ready? You guys look excited. I can tell that's your excited face you got on. All right, tell me about your amplitude. Okay, so if you say a -2, I'm not going to mark it wrong. Technically, it's impossible to have a negative amplitude because it's talking about the distance of something. So I kind of think, though, that it is more valuable for us to understand a negative because we know that something else is happening, right? The negative does what to the function? Flips it upside down. So if you've got John Travoltas that are flipped upside down, what happens? The left arm goes up, okay? So we are now going to have a dance party with left arm John Travolta's up. Okay, what is my b value for this? 1/2. So we're finding the b value the same exact way as we did before. Everybody okay with that b value? Okay, so super fast. I think this is valuable. What is my period? Good, so it's 1/2 of pi. Very good. Okay, so tell me where your first vertical asymptote is going to lie. So at -pi/4. So it's up to you how you get there. Okay, you can use the little formula that I gave to you that said b times pi/2, or you can find the period and divide it by 2. It'll get you to the same place. Okay, the other one is going to exist at +pi/4. Okay, so now for your reference point, we're going to go half the distance of there. So what is my x value for the very first reference point? Good. -pi/8. Now does everybody see where this 2 comes from? Where does it come from? It comes from the amplitude, right? So they're pulling it straight out of the amplitude. Remember that on that first point, the left arm went up. Okay, so that means that's going to be a positive amplitude because of that reflection. Okay, what is my next x value? 0. Okay, what about my third one? +pi/8. Okay, so now all I have to do is graph that information. The first thing I'm going to draw is my vertical asymptote. So where's my first vertical asymptote? At -pi/4, so it's going to exist right here. Down here, +pi/4. Okay, and then I'm going to draw my 3 reference points. Where is my first reference point laying? Okay, so is everybody thinking this in their brains? So I'm going to go half the distance between the x, or the origin, and pi/4, so pi/8, and then I'm going to go up to 2, so there's my first point. 0, 0. Okay, and then halfway to the right and down my amplitude of -2. There it is. Okay, so now you have to draw a John Travolta, which is almost one of the hardest parts of this. Through those 3 points. Oh, I missed. Let me try again. Yes. How do I find vertical asymptotes? So there's 2 ways to do it. You can take the period and divide it by 2. That's one way. The other way is for vertical asymptotes, you will always have x equals b times pi over 2. That will always work. So you'll always have a plus or minus on that. So if you want to write that down to find vertical asymptotes, you might want to do that. Does that make sense? Okay, should we do one more? No? Yes? Of course I want to. What else have I got to do? Alright. So first thing I'm going to list is the amplitude. Tell me what the amplitude for the -3 times the tangent of x over 2. -3, fair enough. So by the way, what arm of our John Travolta will be up? The left arm up. Tell me what the b value is. 2. Everybody okay with the 2? Okay, so quickly I'm going to list my period. 2 times pi, so therefore my period is 2 pi. That was pretty straightforward. Vertical asymptote. Where will I see my vertical asymptotes? Okay, so everybody okay with saying 2 pi and half of 2 pi is pi. Good, so we'll have one at positive pi and one at negative pi, so we can call it plus or minus pi. Be a little quick on that. Okay, my reference points. Okay, so this you need to draw 3 different reference points. Where's my first one going to exist? Negative pi over 2, so I'm going to the left, halfway between my vertical asymptote and the point. How high do I go? Positive 3, because I'm going up with my left arm up. Good. Second point, 0, 0. Third point, -3, very good. There we go. Alright, so now we just graph this information. I'm going to graph my vertical asymptotes first. So I have one at negative pi, one at positive pi, and then I'm going to graph my 3 points. So I have one at negative pi over 2 and up 3. I have one at 0, 0, and one at pi over 2, -3. Everybody okay with graphing that information? Okay, and then to the best of your ability, draw a John Travolta through that. Ooh, that was pretty good. What's that? It is kind of hard to do. You're right. Do I need to do any more examples, or do you feel okay about this? You ready for it?